Okay, so let's wrap that up. Gradle. So, all right. So we briefly talked about and Maven, and both of them, XML based and so on. One of them is kind of totally localized. You can have the full flexibility of specifying everything yourself. So in end, whereas Maven is kind of the opposite. They go down the road. Okay, let's introduce conventions to make things or make life for professionals easier, to develop best practices that work for different developers and different libraries and so on. Plus the major benefit, integrate this central repository kind of thing. So it's a lot easier to maintain your projects, easily integrate the latest version of resources, but just ticking the version number basically. So that was one of the main improvements there, of course. And based on this experience, basically, on all the stuff that has been built over the years, for example, we have Gantt, which is kind of a Groovy DSL that works based on N, so it refines it and makes it programmable as opposed to just using XML. You actually have can use Groovy for that purpose as well, which is kind of a Java-derived programming language in the widest sense. Gradle came about in the sense that it's kind of trying to integrate and make the best word of all of it. It borrows statefulness for dependency management and while retaining, for example, the Maven libraries, but also shifting, for example, the formatting specification and shifting to a different syntax because it's now actually native Groovy. It's a DSL written in Groovy programming language, which has, of course, advantages but also challenges. But one of the major advantages, of course, compare those two ones. The same thing, the top, you don't need to read anything. Just look at the top thing that's written in Maven, look at the bottom thing that's written in Gradle, right? So they're doing the same kind of thing. And that's fundamentally the idea here, that it's so much shorter and more concise in the representation that you can do. So here in the bottom, this is basically how you get dependency for JUnit, similar to what I showed you before. Well, this is how it works down here, right? When you do compilation in conjunction with tests, that's the thing you need to organize somehow, figure it out where it is. And it's also much more legible because you can specify here which repositories are supposed to be used. Well, please use Maven Central. So it's one of the repositories that's kind of hard-coded into Gradle from the get-go. Cool. All right, but a bit more background. Okay, what's actually happening? What does Gradle do differently? It's cross-platform, so it's totally open. It's no longer just primarily focused on Java, but also includes support for C++, Scala, and other languages. So it's kind of flexible. As the transitive dependency management, so basically means it looks up which dependencies your dependencies have and downloads those as well. So it's a bit clever about this and actually resolving dependencies trees. For example, here, if you have your software artifact is number 7 and you are relying on dependency 11, well, Gradle will also figure out that it most likely require dependency 2 and 9 and so on, and 10, of course, in order to build 11, so you can build 7 and so on, right? So that's the idea. That's kind of in a graph representation, a directed acyclic graph, which is like a structure that ensures that guarantees that there's no recursion in your model by avoiding undirected graph relationships. So it's always pointing in one direction, and this node, for example, could never reference back to 7 or 11 or any of that one. So that's guaranteed by the very structure. So, but using this feature, it becomes much more straightforward to manage dependency, but also manage state, because you can keep track of the individual dependency state in terms of build and compilation. I mentioned before, in Maven, it would always operate stateless in the sense it would start from the beginning again and perform all the individual steps, even though they all were successful. It would download all the stuff again, compile all the stuff again, even though it had been done before, whereas Gradle can actually keep track of this, of the latest state, and doesn't need to do this unnecessary work. At times, though, it's a bit surprising because even Gradle sometimes seems a bit slow, at least on my machine, when it's doing its stuff. But in contrast to this, for example, if you run Maven, I'm not doing that exercise right now on your machine. It always felt it's downloading the entire internet because it's really downloading so many dependencies for itself. First, it's downloading itself. It's downloading its own repository management system and all the kind of plugins it possibly has. It comes really neatly, tinily packaged, but once it actually starts its operation, you are suddenly a few gigabytes short of your hard drive space. So it was really, really big in terms of building up, but kind of very reliable infrastructure. So this is much more lean compared to this. So it's built on Groovy. It's a mix of declarative and imperative code. So you can actually the declarative part is basically what you saw right now, the configuration elements that easily allows you to specify properties that are then automatically used in the backend. But of course, you can also be declarative. I show you imperative. I show you that in a second, where you basically say do the following. You can do multi-project builds. Of course, what else did I want to say? And it optimized for incremental builds. So if, again, part of your solution is already built, it doesn't rebuild it again. And it does do parallel execution as well. So Maven doesn't do that. That's one after the other. Here, however, for example, if you have dependency 2 and 9, those could be built in parallel, right, before they're integrated when dependency 11 is, for example, built, right? Gradle discovers that or realizes this and actually organizes the execution accordingly. So you have much more efficient usage of your compilation environment, right? So what it also does, quite cool, is actually supporting reporting. So you can actually post reports into CI system, for example, and see, oh yeah, this build actually worked out well, or it doesn't, or whatever else. So you can integrate it with external resources quite easily. Cool. So fundamental components of Gradle. So we have a build script, of course, which contains one or more projects. We have a project which is a component to be built fundamentally. So kind of multiple projects, of course. And the component or the project contains one or more tasks. So it's kind of similar to AND again, same kind of problem, target, and tasks. Here's project and tasks, right? And task is a distinct step in the execution, very much similar to AND as well, and it's meant to be modeled atomically. So it's actually meant to execute or not execute, but not have any sort of intermediate state, right? So you really meant to reduce it to pretty much to one command in execution, not to make it complex. And that's important, of course, because you can program tasks yourself, so you need to get that right. And yeah, the publication aspect, the output, is kind of a fundamental characteristic. So in the backend, how does it roughly work? By the way, I took most of the insights from the Dr. Dobbs journal, which unfortunately is no longer published. It's a really good text journal that was highlight latest developments in a corresponding area and provide overviews on. It was fairly well recognized, so it's quite a pity it actually shut down. But anyway, so how does it work? We have the Gradle build script, which basically serves as a configuration file. So the stuff you always see or saw in your Android Studio as a configuration file for the actual Gradle API that just consumes that build script and does a lot of different stuff basically. So it basically checks for the project and sees, oh, hang on, is there repository specifications, for example, handles over to the repository handler, for example, that figures out which repository and how to access the particular repositories. Maven Central as an example, but there are a few other ones I'll show you in a second. Are the dependencies that I mentioned, for example, JUnit in my previous example, that's delegated to a particular handler dealing with this and so on. And if there are task specifications here, so my task is an example, in case you can read it here, that's basically delegated to the task interface handler, which kind of parses the content there and actually performs the corresponding actions. And individual actions are just executed atomically as well. So that's basically how the entire Gradle specification is broken down in terms of the API on the corresponding functionality. So quite straightforward. Similar to Maven, again, what it inherits from it, and you'll find that very rigidly and strictly in Android Studio, you don't have much influence on the structure of your project. Right? Source code is structured a certain way. When you create a layout, it's in a layout folder. When you create Java code, it ends up in a Java class folder and so on. So that's the thing here as well. The layout is kind of given as part of the convention that comes with Gradle. So again, this is borrowed from Maven there as well. And there are certain properties that you can just use as part of a convention. Dist name means, well, distribution directory name. Or source compatibility basically means, okay, which version of compiler do you want to compile it against, and so on, right? So quite relevant. And then there's the conventional build lifecycle that would just mean build everything, use the classes, combine them to jar files, assemble that whole thing, and finish the build process. That's roughly what it does. So relatively quite straightforward, nothing entirely new. In fact, it's really backward compatible in the sense that it consumes end scripts, so you can use end scripts from within Gradle, which is pretty cool. So if you have old dependencies, you can just use them and use the build XML file, which will work. Maven can also be used to some extent, but it requires conversion, so into Gradle files. But it's relatively straightforward, so you can automate this as well. Yeah, that's basically what it can do. It can also rely on end tasks. The built-in tasks that I showed you before, or that operating system level activities that you can perform in end, you can also call those from Gradle as well. And last but not least, it's linked to the Maven repository. So it's a really nice way of integrating a lot of the previous tech. That's why I'm bringing all this kind of history up as well, to kind of have you guys appreciate how it grew over time. And also, if you come across a build XML file and a POM XML file, you kind of know what you're up against. You at least know, okay, hey, I need to look into Maven or end. But Gradle is also a good sub option because it can consume most of those as well. So structure-wise, well, we have projects that we define in terms of dependencies. And if you want to specify, for example, file dependencies, you can be very explicit. So you could say, here, compile this project shared or whatever as a dependency for my actual project, or you can use individual files on your file system as well. That's quite neat as well, so you can actually access your file system as well. Repositories are the Maven ones, Ivy ones, the artifacts, that was that one. Dependency configuration, yeah, that's a nice one. So just to give you an example, I think it's always done best with some sort of inspiration. Let's see, we'll find something. Right. So this is basically the volley demo I showed in the last session. And you see here, I'm going into the different files and what they mean in a second. But before we do that, if you see the dependencies here, you see, okay, here's kind of a keyword that says, what do you need them for, the dependencies, and then also what dependencies you're actually going to use, right? So for example, for the implementation, for the actual compilation and running, well, you need access to the libs directory and particularly all the jar files of the libs directory. What you also need is this library here, the app-compat version 7 library. So that's the compatibility package for Android, right? So it supports newer features on all the devices or ignores them. And the constraint layout needs to be loaded as well, right? So for example, for tests, meaning not for the implementation, but if you want to run tests, you need that dependency here. In this case, JUnit 4.12. It means, well, while you need it for your testing, you actually don't need it for the deployment, right? So you actually can differentiate for the dependencies that you need doing build and testing as opposed to the actual installation of something, right? So that's a rough idea here. And here basically specify the packages you're interested in. And you can be specific and say, hey, I want to have JUnit 4.12, but you can also be flexible and say, I actually want JUnit 4.12 or higher. So that would be a dynamic specification of dependencies. Of course, bears incredible risks, right? So because it will always go for the highest version of that corresponding dependency, which may just break. But it allows you to kind of automatically keep your dependencies up to date if you want to, right? Within at least the boundaries. So that's what they refer to as static versus dynamic dependency configuration as shown here, right? So we talked about transitive dependencies. Your parent project has certain dependencies and your child project has dependencies. Figured those out and deals with this one. Right, and some general rules for execution of those build files. Of course, for dynamic dependencies, higher versions are better, so it's preferred over lower versions. The metadata information goes over artifact information, so metadata information that's provided as, for example, the POM file is more relevant than the artifact snippet that you put into your Gradle configuration. It's not super relevant because it suggests the interaction with Maven, but more relevant perhaps is if you have different repositories that you specify, for example, the Maven repository or the Google Maven repository, I'll show you in a second, it will take the first one over the later ones. That's the key idea there as well. Yes, so yeah. Yeah, so, okay, so, right, the execution steps is quite straightforward. What it does, it will initialize the build system, resolve all resources, develop the dependency graph, and proceed with the actual build. So that's how it works, actually, right? So you have the, trying the local repository, assess the artifacts. It caches stuff, of course, the stuff that it has built before, so it can keep track of the progress in the build process, and where necessary, uses the external repositories as well. Right, now to the model, to project structure. If you look into Android Studio, you will always find something like this. You have your app on top, which is your project, and you have your Gradle scripts on the bottom. And seemingly, you have multiple versions of the same script, which is kind of annoying. But one of them is tagged with project, the other one with module. And that's the thing. So the one tagged with project is the top level one. This is the highest level Gradle file. And the one tagged as module is basically a project-specific subdirectory that you are used to refine. Properties are generally managed in the global Gradle properties, and there's also a Gradle wrapper that it can take additional properties. We talk about, or we see, look at this thing in a second, so it doesn't really matter too much right now. But more importantly is the fact that you have two build.gradle files, and one of them is project related. Let's, for example, see here. I got wrong button. There you go. So what do we see here? Well, on the project level, the top highest level, what does it do? It's the build script that specifies repository, and you see two there. So there's Google as a repository. So Google also has a Maven repository that it publicly is publicly accessible, and this is encoded into Gradle itself. So the URL, you don't need to worry about it; it's part of it. And JCenter, what was that one again? Don't know. It's a different. Also repository centric. So multiple ones, you specify the dependencies here, and it has additional task that's called clean, right? If you run the Gradle task clean, it basically will delete the, well, build directory of the root project, right? You can probably gather that. Right, cool. So that's the project level tasks and project level functionality. But if you look at the lower build Gradle level, here it becomes more interesting because that's specific to the fact that it actually recognizes your application as an Android app. And you can see it here. It says apply the plugin com Android application, meaning everything follows, uses primitives, specification primitives that are from that plugin. For example, compile SDK version is specific to Android, right? So in fact, everything in the Android section here is specific to Android. Min SDK version, target SDK version, and so on. That's not part of Gradle itself. Gradle is not only for Android, right? Gradle is a generic build system, but it has selected plugins for different environments. And one of them is just Android that supports all those specifications. So that's where you set up basically all the different properties and can configure different builds as well. For example, you have different build types, and it says, for example, for release, well, don't minify stuff and apply those following ProGuard rules. Don't worry about that stuff right now. Basically just parameters that apply in the context of the release build that we do. We talk about that stuff later on at some other time again. And as I mentioned before, or showed before, specific to the Android application, those are the dependencies, right? Those are dependencies at implementation, those are for tests, and those are for Android tests. So again, that's very specific to the Android environment. But that's the idea there. So I hope that you get a better understanding of the differentiation between those different Gradle files and why they actually, well, hopefully make sense, right? So there's some additional properties you can set. You can, for example, tell Gradle how much RAM it's allowed to use. In this case, it's 1.5 gig for its operation, if that ever is necessary. And here it says just project settings. Yeah, it says, well, you know, what projects do we include? We just include app as our module as part of the project. That basically links the two files together fundamentally. So, cool. Just contextually, here, by the way, are the URLs. JCenter, that's the one. So those are the kind of repos that are built into Gradle as well. So you can just call Maven Central, Google or JCenter under repositories. Now you know, okay, it's just basically just pointing to different repositories. You can, of course, use your own one as well by specifying it as shown down here. Quite straightforward, really. I'm not going to this one. Right. So yeah, basically this is kind of a figure, kind of giving you a structural overview, right? So you have the project on top that is managed using the build.gradle file and settings.gradle file, and the major file, and then the module basically that contains all the rest, including the source directory. And the source set, that's basically all the information relevant for compilation, is managed under source, following the standard layout for Android applications. So if you change the layout, screw it, they're gone, right? So if you change the structure of the file system, it will not work for you. Okay. So as I mentioned before, this thing is to some extent at least programmable, right? So you can actually easily integrate your own tasks as well. But also you can actually automatically execute the entire system. So hang on. So you're not necessarily relying, for the build process, you're not necessarily relying only on Android Studio, for example, but there's actually a tool called GreatW that can actually help you in this process. So if you run this thing, it basically just starts like a daemon in the background. It runs the daemon because it wants to keep state of track of state. So therefore, it's kind of running that in the first place. And basically now it figures out, okay, cool, I found some build.gradle file. I'll just do stuff, right? So, and it did something. It basically just ran and checked the layout. So if I run Gradle tasks here right now, let's see what I get. It shows me all the tasks that are basically available. Oops, and there are quite a lot of them. So I can just decide which one I want to actually run or execute if I want to do that, right? So you could. So yeah, there are default tasks that are built into the system, for example. But I can also go as far as to, let's try that one, actually specify new tasks on our own. So we're kind of flexible in doing this. Standard example. I think this is the syntax. Luckily, there's some syntax highlighting. Good, lucky me. And then print line is kind of borrowed from the, it gets rid of parentheses. Starting count. And then I do stuff like do last. So you can organize the order, the execution of tasks within, which is of course quite important. And then you do something here, for example. Classical approach is kind of an inline specification of functionality. It doesn't show in the syntax highlighting, but you do something like if you want to have a loop that extends across 5 times and does something for you, for example, printing stuff, printing new line, you can easily do this in the code itself. So hang on, is that correct? So let's see if that picks up the new tasks anyway, or let's see if we can find this task anyway. Gradle count. Ah, yeah, it actually does it. So it actually figured out the tasks. So and you basically just executes the task count, which is just doing something first. In this case, saying that it wants to start the count, actually doing the job. And if you say Gradle W tasks, it should also list it in the list of tasks. Let's see if we find it. From root projects, I don't see it right now. Anyway, that doesn't show up here in this setup right now. Anyway, so, but fundamentally that's what you can do. You can actually encode your own stuff. So you can imagine, you can modify files, you can delete files, you can organize, you can shuffle stuff, you can do additional user output, and so on. So there's quite a bit of stuff you can suddenly do, which is close to, impossible, I would say, or very hard with Maven anyway. But you can basically use pretty much the entire Java API and do anything what you can do with this one in this way. It's just a slightly different syntax. They got rid of semicolon, parentheses, and standard packages that they import without you explicitly importing them. So it's one of the major advantages of Gradle. Yeah, one cool command, for example, is also if you have a project and you just want to quickly figure out all the dependencies that you have in that project, you can also automate this one. That will not work. So saying, okay, please show me all the dependencies that this project has, and then you can quickly see, ah, cool, okay, that's what I'm relying on in my life here. Anyway, sometimes can be quite helpful to actually see what you're actually using and what you're using of a given library or within a given package. Anyway, so quite neat feature. I put those commands that are probably or perhaps relevant for you or sensible here on the slide set as well. But that's fundamentally what you can do. So you can use GreatW, use it for testing. We talk about testing, you can do that as well. So basically tests would be also tasks. So you just say GreatW and then a corresponding test. It does it for you, building, deployment, and so on. So something you can easily automate. The fact that we use Android Studio does not limit the headless execution at all. So it's quite neat. Cool. Yeah, you can of course, before I mention that, forget that. You can also create reports of your scans, actually publish them online. So if you do that, you can just say GreatW build and then provide a scan. And you can say, yeah, I want to publish this as well. So, and then when you do that, it spits out a URL. And then you need to activate it, admittedly, using your email address. So saying, that's actually mine, because you may, so to identify you potentially. And then it will publish the results of the new execution of Gradle. So it's an easy way of deploying it somewhere centrally or keeping track of build success or build failure. And that's basically how you do it. That you say, I want to integrate the plugin build scan, and you say, you configure it for after that, basically saying this URL, this is the terms of service, and I want to agree, and then basically just publish always, and it would just return you URL to show what you actually did. Cool. So that's basically the overview I wanted to give. Here's some of the Android-specific options. Note if you're dealing with older Android, I'm not sure if you had that problem. If you're opening older Android projects, you sometimes get the comment, hey, your Gradle version is out of date. You need to upgrade to version 3 or whatever else. And after that, your things blow up in your face because they say, oh, hang on, you're using old dependency specifications. For example, compile has now become implementation. Every time you see compile, and then a corresponding package, it says this dependency is used in the compile stage, but now the term for that is implementation, right? So, and so on. So there's some variation in the API for Gradle 3. So bear that in mind in case you have those weird errors. They will generally are quite descriptive in a sense. They're suggesting, okay, please change those terms, but just bear that in mind. That's maybe quite relevant. Cool. Well, yeah, as usual in life, more features in Gradle 3 onwards, but we are there already. We come back to that. The main reason for talking about Gradle is really so you actually know what you're doing when you look at it, or at least get an understanding what it does behind the hood, right? That it basically uses the configuration files to instantiate the build and perform it. And so you can kind of modify it as well and use it for your purpose, or use it to automate testing or whatever else. It's something you need to play around with. Have a look at the website, of course. The Gradle documentation is actually fairly good. There's also a book out there, of course, that deals with this, but I think the website does a good job in getting you going in a way, because there's also kind of a tutorial of how to get started, which is a bit more tedious with the older versions anyway. But anyway, so at least you know the tool is out there, what it does, and you can go from there. Questions? Cool. Well, that was a bit long one. The usual Tuesday afternoon rant. So it just happens to be so. But I understand you probably had a lot of class already before, but still worthwhile kind of bearing in mind in your practice as Android developers. Other than that, I'll see you tomorrow morning, I believe. How many do I see tomorrow morning? Okay, the core crowd. Ah, there's commitment there. That's cool. Yeah.
It takes half an hour to go here and half an hour to go back, and that's taken from my free time rather than schoolwork. So I'm going to watch it over the internet instead.
That's fair enough. Yeah. Okay. I like your rationalization that comes with it. So that's quite sensible. Now, of course, you can always follow it via stream anyway. There's no harm. But of course, it makes more for, I guess, oftentimes learning may be better if you are there as well.
Yes,
but
when I can bicycle, I'm probably going to start going to all the classes.